Okay, so when we have a situation where one triangle is included in a bigger triangle, and two of their sides are parallel, remember these little arrows mean that the sides are parallel, then we have some corresponding angles. So if BE is parallel to CD, then angle BEA is corresponding with CDA, so those are congruent. So these two angles are congruent, and technically angle ABE and ACD are also corresponding, so they're congruent. And in the little triangle, angle A at the top is one of the angles, the three angles of the triangle, and it's also one of the three angles of triangle AC. So these two triangles are similar by angle. So we can prove that these two triangles are similar by angle when those two sides are parallel. So if these two triangles are similar, then their sides are going to be proportional. Well, to redraw the big triangle separate from the little triangle, and then we'd have to like add AB and BC together to get the whole thing AC. But when these two sides are parallel, and only when those two sides are parallel, we have to know that the two sides are parallel, then we can say that this segment is dividing these sides of the triangle proportionally. So if BE and CD are parallel, we can just say AB over BC should be equal to AE over ED. Top over bottom equals top over bottom. So AB over BC is equal to AE over ED. So in our example, if EF is parallel to CB, then we can set the proportion 18 over 6, top over bottom, is equal to the top over the bottom, x plus 22 over x plus 2. So I'm just going to cross multiply, but these are pretty big numbers, so I'm going to try and reduce that fraction just to make my life a little bit easier. This step is not necessary, it's not required, but it is helpful. 18 over 6 reduces to 3 over 1. So now when I cross multiply, I'll do 3 times x plus 2 is equal to 1 times x plus 22, so it's just x plus 22. Sorry, that's an x. Then I'm going to distribute the 3x plus 6 equals x plus 22. I'm going to subtract the x to get 2x, subtract the 6 to get 16, then divide by 2, and x is 8. Now the converse of this triangle proportionality theorem is also true. So if I can check the ratios and see that they're proportional, see that those sides are being divided proportionally, if I can plug numbers in or something and set up these ratios, if I can check and see if AE over EB is indeed equal to CD over DB, then that's enough information to say that those sides are parallel. So in this problem, we are told that HK is 5, that KG is 10, and that JL is 1/2 of the length of LG. So I don't know what LG is, so I'm going to call it X. So JL is going to be half of that, so JL is half of X. So I want to check and see if HK and KG, if that ratio is the same as the ratio of JL to LG. So I'm checking to see, is 5 over 10 going to give me the same thing as 1/2 X over X? So 5 over 10 reduces to 1/2. And then 1/2 X over X, the X in the numerator and the X in the denominator cancel out. So that's just 1/2 over 1, which is just 1/2. Oh my gosh, they're both reducing down to 1/2. So yes, they are proportional. So because HK over KG was equal to JL over LG, that means that HJ has to be parallel to KL. So yes, They are parallel because I set up the ratios and checked to make sure that they were equivalent.